students, welcome back. We're going to watch a video lesson on section 6.4, example 1, and I'm going to teach you today in this example how to add and subtract polynomials. So as you can see, we're looking at letter A, and you notice we have some like terms here. So let me underline those like terms, and there they are. What we want to do is we want to put them together. The key to addition and subtraction of polynomials, all you do is add the coefficients or subtract the coefficients, whatever the case may be, and you combine the coefficients only. You don't change an exponent on any of those variables. The only way you can change an exponent is if you're multiplying the same base to each other, you would add the exponents. If you're dividing the same bases, you would then subtract the exponents, or if you're raising a power to a power, then you would multiply the exponents. We're not doing any of those in this lesson. We're just learning how to add and subtract polynomials together. So what I've underlined is 15m cubed and 2m cubed. And the way that you would look at this, you would say if I have 15 m cubes piled up, and I add 2 more m cubes to the pile, how many m cubes do I have? And hopefully you said, oh, 17, because 15 plus 2 is 17. And then you would just drop down your 6m squared, because m squared and m cubed are not like terms. Remember, a like term is a variable that's both the same and has the same exponent on it. M cubed is much, much different than m squared. They are not considered like terms. And so therefore you would be finished. This is the best you can do in simplifying this particular answer. You've combined your like terms, okay? So that's going to be the key. Let's put that as a note up here. Combine like terms. Don't change exponents when adding or subtracting. Okay? That's really important. I have a lot of students who would have taken 15m cubed and 2m cubed and gotten 17m to the 6th. There's no way you can get m to the 6th out of that unless you multiplied m cubed times m cubed. Then you would add the exponents if you multiplied those bases together. We're not multiplying, we're adding like terms together. So we just want to add the coefficients. That's what you should be focusing in on. All right, let's shift over to letter B. We've got 3x squared and negative 7x squared. They have the same variable and the same exponent on that variable, so we need to combine them. So take the coefficient 3 and the coefficient negative 7, and let's add them together. What's 3 and negative 7? You could either look at it this way, 3 plus negative 7 or 3 minus 7. However you look at that, you're going to get the same exact answer. And if you got negative 4x squared, you're exactly right. Now you have another set of like terms right here. You have a constant number of positive 5 and another constant number of positive 12. You need to add those together. 5 plus 12 is positive 17. So we'll put a plus sign and we'll put a 17 there because 17 is positive. That's why you put the plus sign there. All right, now negative 4x squared and 17, they are not like terms. So you can't combine them, and you're done. This is the best you can do in presenting your answer. That's the most simplified answer you can present. All right, let's go down here to letter C. Let's see. Okay, I see y. I see a y to the 5th. Here's another y to the 5th. And here's another y to the 5th. Okay, so I like to kind of underline, at least you can highlight it, you can underline it. Whatever you need to do to kind of point out where those like terms are. So what we want to do is we want to take 0.9 and subtract 0.4 from it. Well, that's 0.5. Now, you have another y to the 5th term out here that has an understood 1 in front of it, okay? So we want to take our 0.5 and add 1 to it, and that gives us 1.5 y to the 5th. And then this guy right here, there is no other x to the 5th term up there, so you just drop it down, plus 0.5 x to the 5th. Okay? Now what you could do in this situation is if you wanted to go a little bit more alphabetically, you could do that. You could say, okay, 0.5 x to the 5th plus 1.5 y to the 5th. You could do that. Now because they're different variables, you can't combine them, and that has to stay your answer. This binomial, this quintic binomial has to stay just like this. Okay? All right, let's look at letter D. We've got x squared y, and x squared y. So all of them are like terms, all three of them. It is important that you show yourself, okay, that's actually, there are ones in front of those other x squared y's, okay? So you've got 2 minus 1, well that's 1, and then 1 minus that last one is 0. Well, 0 times anything is 0. So you don't need to show the x squared y because anything, the coefficient is 0 and anything times 0 is 0. So we'll just 0 that out. Hopefully this is seeming to you to be pretty easy. All right, let's look at letter E. We've got 2s squared and 3s squared. Hey, those are like terms, so all you need to do is add the coefficients. 2 plus 3 is 5. So now I have 5s squareds when I put them all together, and then I'm going to drop down the plus s. S is not a like term with s squared. So you don't combine them, you just drop them down, and this becomes a quadratic binomial. That's what we learned in 6.3. Okay? Now, I've done quite a few for you, and I want you to show me tomorrow F, G, and H. Combine like terms, and go ahead and put them in standard form for me. We learned that in section 6.3, so you should know what standard form is. Okay? So I'll give a +1 for each of these that you attempt. Please attempt all of them. There's no reason not to try. That gives you 3 extra bonus points on your bonus log this semester. All right, that's it for example 1. Thanks for listening.